A cylindrical tank of diameter 35 centimeters is full of water. If 11 liters of water is drawn off, the water level in the tank will drop by how much centimeters? So this is the cylindrical tank. Let us assume that the water has dropped by h centimeters. Now the volume of the water will be equal to the equivalent volume of this much of the cylindrical tank, that is empty, because 11 liters of water has been drawn off and water level fell by h centimeters. So the equivalent volume will be equals to the volume of this cylinder with height h. Okay, so I can say that 11 liters, that means 11 into 1000 centimeters cube, is equals to the volume of this equivalent empty cylinder, this equivalent empty space. So I have 11 into 1000 is equals to volume of this empty space of this cylinder is pi r square h. So pi r square h, right? So this is 11,000 is equals to 22 by 7 times, well, the diameter is 35 centimeter, so the radius will be equals to 35 by 2, isn't it? So r square is 35 by 2 times 35 by 2 times the height. Now h is the drop in the water level, and that's what we have to find out. So 7 times 5 is 35, 2 times 11 is 22, and this 11 times 1000 is 11,000. Okay, so we have h is equals to 1000 into 2 divided by 5 into 35. Now 5 times 200 is 1000. Again, if I divide 200 by 5, I get 40, and 5 times 7 is 35. So 40 times 2, that's 80 by 7, is equivalent to 11,3 by 7 centimeters. So that's the drop in the height of the water. So option B is the correct answer. What is the number of coins of radius 0.75 centimeter and thickness 0.2 centimeters required to be melted to make a right circular cylinder of height 8 centimeters and base 3 centimeters? Let us consider that the number of coins required is n. Now n coins are melted to form a bigger cylinder. So I can say that the volume of cylinder is equal to n times the volume of one coin, right? The point is the volume should remain same. Now what is the volume of a cylinder? Well, it is pi r square h is equals to n times the volume of one coin. Well, the coin is also a cylinder, but a very small one. So this will also be pi r1 square h1. H is basically the thickness of the coin. So this pi and this pi gets cancelled out. We have r square. What is the radius of the cylinder? Well, the radius of the cylinder is 3 centimeters. So this is 3 times what is the height of the cylinder? That's 8. So times 8 is equals to n times we have r1 square. What is the radius of the coin? Well, it is 0.75 centimeter. So 0.75 times 0.75 times what's the thickness? Well, 0.2. So 0.2. Let us rewrite it. We have 3 times 3 times 8 is equals to n times 0.75 can be written as 3 by 4, isn't it? 0.75 is 3/4. So this is again 3 by 4 times 0.2 can be written as 2 by 10, or in other words 1 by 5. Okay, so this 3, this 3, this 3 and this 3 gets cancelled out. We have 8 is equals to n by 4 times 4 times 5. So therefore n is equals to 8 times 4 times 4 times 5. Okay, and that will give you 640. So 640 is the total number of coins required to be melted. Option D. 66 cubic centimeters of silver is drawn into a wire 1 millimeters in diameter. What will be the length of the wire in meters? Now a wire is basically a cylinder, and we have been given the volume of the cylinder. Okay, that's 66. So volume is equals to 66 centimeters cube. Okay, now what we want is the length of the wire, that is the height of the cylinder, and we have been given the diameter of the cylinder, and that's 1 millimeters. Okay, so the radius will be half of the diameter, that's half of 1 millimeter, so that's 0.5 mm, and 0.5 mm is basically 0.05 centimeters. Okay, so we have got the radius, we've got the volume, we can calculate the height. So what's the volume of a cylinder? Well, it is pi r square h, and that's 66. So 22 by 7 into radius is 0.05 times 0.05 times h. Well, h is what we have to find, is equals to 66. Okay, now 22 times 3 is 66. So we have 1 by 7 times 0.05 can be written as 5 upon 100 times, again we have 5 upon 100 times h is equals to 3. So 5 times 20 is 100, here also 5 times 20 is 100. So h is equals to 3 times 20 times 20 times 7. Right, so 3 times 7 is 21 into 20 times 20 is 400, and 21 times 400 is 8400, and this will be in centimeters. Okay, now 8400 centimeters is 84 meters. So the length of the wire is 84 meters. That's option A. A cylindrical tube open at both ends is made of metal. The internal diameter of the tube is 11.2 centimeters and its length is 21 centimeters. The metal everywhere is 0.4 centimeters thick. What is the volume of the metal? So this is your metallic tube, which is hollow from the inside, and this gray portion is the metal. Now you have been given the length of this metallic tube as 21 centimeters. Now this tube is basically a cylinder, so I can say that length is basically the height. So height is equals to 21 centimeters. Okay, now you have been given the internal diameter of the tube. So this distance, that's 11.2, is given to you, and you have been given the thickness of the metal, and that will be this distance, and this distance is 0.4 centimeters. The metal is 0.4 centimeter thick. Now you have been asked what is the volume of the metal. Well, you can consider a problem like this. You have basically two cylinders, and one cylinder is inside another cylinder. Now you have to calculate the volume of the space which is in between those cylinders. So what you can do is, I can say volume of this space, that is this gray space, is equals to volume of the outer cylinder minus the volume of the inner cylinder. Okay, now to calculate the volume of the outer cylinder and the internal cylinder, you have to find out what is the radius of the outer cylinder and the radius of the inner cylinder. So you have been given the diameter of the inner cylinder, that's 11.2, so the radius is 11.2 by 2, and that is equal to 5.6, and this will be in centimeters. Now the outer radius will be equals to the inner radius, that's 5.6, plus this thickness, right? So plus 0.4, and that is equal to 6 centimeters. So you have the outer radius and the inner radius, and the height of both the cylinders is same. So this is equals to pi r1 square h minus, we have volume of the inner cylinder, that's pi r2 square h. So taking common pi and h, so we have pi h times r1 square minus r2 square. Well, you can apply a formula here. We have a square minus b square, so that can be written as r1 plus r2 times r1 minus r2. Oh, we should have called these ro and ri. So Not a problem actually. Let us do it. RO and RI. Okay, so we have 22 by 7 times 21, right? The height is 21, times we have RO plus RI, that's 6 plus 5.6, and multiplied by 6 minus 5.6. Okay, so this is equal to 7 times 3 is 21. We have 22 times 3 times 11.6 and 0.4. Okay, so if you solve this, you will get 306.24, and the unit will be in centimeter cube. So that's the answer, option B, the volume of the metal.